Hello there. My name is Tom, and I'm a graduate student here at the University of Maryland. Today's video is going to be about the roaring tube demonstration. Here I have a tube of air, and inside we have a heating coil that's connected up to a circuit. Once I flip this switch right here, it's going to connect the circuit, and the heating coil will heat up all of the air molecules inside the tube, which will then expand and contract and start to vibrate back and forth. My question to you is, once that happens, what do you think is going to happen with the tube? Is it going to make sound at a certain frequency? Is it going to make a sound at multiple frequencies? Or do you think nothing is going to happen? Take a moment to consider the dynamics of the system and make a prediction. Okay, let's give it a try. As we can see, the tube indeed did make a pitch. The tube and all of the air inside constitutes a mechanical system. And whenever a mechanical system is subject to an external vibration, in this case, the movement of the air molecules inside, it will always vibrate at the frequency it's being driven at. In this case, the air inside is moving at all different frequencies. But what we heard was what sounded like a single pitch. This is because the amplitude or intensity of a system's vibration depends on the frequency it's being driven at. And for most frequencies, the system's response amplitude will be very small. However, at what is called the resonant frequency of the system, the amplitude response will increase greatly and dominate over the response at all other frequencies. What we heard sounded like a single pitch. However, what we've done here is we've taken the sound wave that the air tube created, and we've separated the sound into all of its different components by frequency. And we can see that this curve is dominated by a spike at the resonant frequency. But it's important to note that the tube is not only resonating at the resonant frequency, but it's actually creating all different frequencies, most of which has much smaller amplitude, which is why we only hear the resonant frequency when we vibrate the tube. We can also see here that there are several smaller spikes at higher frequencies above the resonant frequency. Now, the system actually has a lot of resonant frequencies called overtones, which correspond to frequencies that are multiples of the fundamental harmonic frequency. Let's take a look at this demonstration one more time, and this time see if you can hear any of the other frequencies. That's all for today. Thank you, and see you next time.